Hello guys, Art-Teeves here. In this video, I want to talk about decals. These are basically images, textures with transparency, that you overlay on top of your main 3D model's texture. They work exactly like stickers. People use them to add small details, cracks, dirt, graffiti, bullet holes, scratches, without touching the model's geometry or its main texture map. What I'm going to cover here is the workflow where we create a separate UV map and bake different elements flat onto a plane. I'll show you how to model simple decals using crease set and OpenSubdiv, how to bake them onto a flat surface, and then how to place those planes onto your actual model. If you are not interested in the modeling part and just want to see the baking or placement, feel free to skip ahead. The timestamps are in the pinned comment and in the video description. In this video, I'm going to create 4 different decals using different techniques and bake them onto 4 separate planes. Each plane ends up with around 100 polygons, way more than necessary, but I deliberately went overboard to show you the most flexible options possible. Obviously, if you are projecting a decal onto something flat like a wall, one single polygon is more than enough. The downside of using fewer polygons is that the plane won't bend or conform very well to curved or uneven geometry. These kinds of decals should always be placed about a millimeter or a few millimeters away from the surface. It's super important that they don't intersect other geometry and don't lie exactly in the same plane, otherwise you'll get Z fighting, that annoying flickering where the GPU can't decide whether to show the decal or the wall underneath, and it keeps switching between them. There's a big difference between the old-school overlay geometry approach and modern decals. You've probably seen overlay geometry in older games, a polygon with a bullet hole just slapped right on top of the wall. The problems were obvious, tons of draw calls every time you shoot, terrible texture blending, it always looked like a cheap sticker, shadows cast by the polygon itself, and if the wall was uneven, your sticker would just float in mid-air. In modern engines we have decal actors and mesh decals. A decal actor is basically a projector. It shines the image onto the surface. The decal perfectly wraps around bumps, cracks and corners, but you can't bend it around sharp edges. A mesh decal is more like a flexible sticker that actually follows the shape of the object. Today I'm going to walk you through the process of baking decals onto a plane, but I won't be covering how to actually apply them in Unreal Engine 4 or 5. There are already plenty of great tutorials on that, and I don't want to just repeat someone else's content. If you want to understand what happens on the engine side, I've linked a really solid guide in the description and the pinned comment. Just to stress it again, I am baking onto planes with 100 polygons each. That's completely overkill. If you are projecting on a flat surface, 1 polygon is plenty. If you need some curvature, go for a beveled plane or a slightly rounded mesh with no more than 50 to 200 polygons. In Unreal Engine 4, you're not actually adding any extra geometry anyway. The decal there works as a projector, not as a physical sticker like the ones you see in my video. That already solves the shadow issues, Z fighting and texture blending problems. In other words, those 100 polygons you see in my footage are basically the old overlay geometry method, where you would place a polygon right in front of a surface and try to bend it so it looks like the part of the wall. You don't need 100 polygons in real projects, but I'm definitely going to show you the bending technique. Just please don't copy-paste this approach literally into your game. I'm only demonstrating the core logic behind it. Alright, now let's get into how I prepare my decals in 3ds Max. First thing, I avoid baking cavities created with negative extrude values. Sharp 90-degree inside corners bake terribly. It's much better to use bevels or chamfers. You can see the difference in this screenshot. As a general rule, I recommend avoiding sharp right angles almost any time you are baking something. Other than that, we are following standard hard surface modeling principles. We are literally creating small hard surface objects, they don't need much height, otherwise you can't bake them properly. And then we transfer that geometry onto flat planes, which will later act as our projectors. Since we are using OpenSubdiv on these objects, we need to avoid tangents and poles. In other words, it's best if your geometry is made of quads or near square polygons. To speed things up, I use the crease set modifier. It lets you set custom crease weights for individual edges or groups of edges, to control exactly where OpenSubdiv sharpens or rounds. Another big advantage of decals is that they won't get blurry the way a tiny object would if you just placed it onto a large wall that's unwrapped onto a roughly 2K UV map. With something like this screw head here, I don't need perfect edge smoothing or super precise curvature. Anyway, a bunch of finer details are going to get lost during baking, no matter what. What I really want is for it to look simple, clean and nice, while still keeping my geometry free of trees and poles. It also makes sense to add some bevels or chamfers around the sides of the screw head, otherwise it will just blend completely into the surface and look completely flat, like it has zero volume at all. Don't make the overall bulge too aggressive, and don't carve the inner plus shape too deep, both will hurt your bake quality. Here you can use the bevel modifier, or simply extrude the geometry inwards, flatten it on the z-axis, and insert it, and finally collapse the edges created by the insert tool. Also avoid pushing that plus in at a sharp 90-degree angle, it's much better to soften that inner edge and make the transition smoother. Finally I go ahead and set up the crease sets. First I select all the edges that are roughly around 90 degrees, plus or minus about 40 degrees, basically anything that should stay relatively sharp. Then I group all those edges into two separate crease sets, one for the outer edges of our plus shape, and the other one for everything else that needs to stay crisp, but obviously skipping any of the intermediate or smoothing edges. This approach lets us completely avoid adding extra geometry by hand, which is exactly what you would have to do if you were using the old TurboSmooth method instead. You may even mess up your geometry a bit here, because there is a high chance that it won't be noticeable after baking. The way crease set values work is pretty straightforward. The closer the value is to 1, the harder or sharper the edge stays, almost like it's completely locked. The closer it gets to 0, the more it behaves like a regular edge under open subdiv, nice and smooth, just following the subdivision rules. I usually set my open subdiv modifier to 4 iterations, that gives a really clean high-res result. And of course, once you are happy with how everything looks, make sure to collapse and apply all your modifiers, or just convert your mesh into an editable poly, so that it gets ready for export or baking. Oh, and one thing I forgot to mention earlier. In these videos I'm using two modifiers that don't come with 3ds Max by default, the Loop Regularizer and the Rapid tools. The Loop Regularizer is super handy. It takes any loop of polygons and turns it into a perfect circle in just one click, really cleans up rounded shapes fast. Rapid tools, on the other hand, can do a bunch of cool stuff. It conforms one object perfectly onto the surface of another in seconds, and it can cap any even-sided open edge loop with clean quads, even multiple loops at the same time. Rapid tools has a ton of other useful little utility aspect in there too. Honestly, in my opinion, it's one of the absolute best free plugins you can get for 3ds Max. Highly recommend checking it out if you're working in Max regularly. When it comes to decals in general, here's my advice. Try to create them right in the context of your actual object. That way it's much easier to judge the right scale, size and level of detail, so everything looks proportional and believable once it's placed. After you are done modeling the individual decals, group them together into one shared texture atlas. It's way more efficient for performance and organization. And for any decal that's supposed to represent something protruding or raised, like a screw head, rivet or patch, definitely add bevels or chamfers. Do it on both the high poly version, so the bake captures nice soft edges, and the low poly plane itself, so it doesn't look razor sharp and fake when bent or viewed up close. Of course, we could just throw our low poly planes into Blender or ZBrush and sculpt in all the details by hand instead of modeling them precisely. That way we could easily make them look uneven, worn, scratched up and properly rough, giving that nice organic lived-in feel. But for a technical or hard surface stuff like this, screws, panels, mechanical details, we can usually get away with just using 3ds Max. It keeps everything clean, precise and way faster to iterate it, especially if you are dealing with repeatable shapes, bevels and baking workflows that need to stay consistent. Crease sets, combined with Open Subdiv, let you play around with shapes and edge sharpness without having to add any extra geometry by hand, and that speeds up the whole process enormously. The baking rules are very straightforward. We unwrap our planes onto separate UV maps, ideally packing multiple decals onto one texture atlas. The dream scenario is a 4K atlas with 16 to 32 pixel padding. I won't go deep into Unreal Engine 4 specifics here, but pulling out textures from an atlas is no problem. You just use the UV offset to make each decal sample only its own little region of the texture. Other than that, I'm just positioning my low poly planes wherever I need them, so we can bake the high poly details right onto them. Don't forget, make sure to convert your high poly objects to editable poly first, or apply all the modifiers on them. That locks in the geometry and makes sure everything bakes correctly without any surprises. I usually name the low poly and high poly versions the exact same thing, just with different suffixes at the end, something like LP and HP. I went ahead and made UV unwrap right here in Max. I don't recommend you copy this part at all. It's way better to build your UV map in whatever program feels most comfortable and intuitive for you, just not the Max, especially not without some really decent plugins. And most importantly, set a proper sensible padding between your islands, don't just eyeball it like I did here. When I'm baking my decals in Substance Painter, here is exactly what I do in the bake settings. First, I turn off the ID map section completely. Most of the time you don't need it for simple decal bakes like these. That said, in some projects the ID map becomes super important if you want to mask or target specific parts of the model during texturing or material assignment, so keep that in mind depending on your workflow. Next I crank up the number of rays to the maximum on every single tab, ambient occlusion, curvature, normal, you name it. More rays, cleaner, less noisy bakes, especially on small details. Then I set my subsampling to 16. It takes longer, but for the decal baking where you want crisp edges and no artifacts, it's worth it every time. And finally, I enable transparency padding. This is crucial for decals with alpha channels. I also enable the transparency layer and change my shader to PBR Metal Rough with alpha blending. In order to conform my low poly planes to the rest of the model, the old overlaying geometry way I've mentioned earlier, I used the Rapid RT Conform tool provided by the free Rapid Tools plugin. You don't have to do this in modern pipelines obviously, so I'm just showing you the outdated logic. As I've mentioned earlier in this video, modern decals are being projected on your models in game engines. And basically this is it. I think this covers everything I wanted to mention in this video. Thanks for watching guys. If my videos are of use to you, please be my guest and subscribe to my channel for more stylized content. And most importantly, have a great day.